We are going to pick up with example 1. So the first thing we need to do is, because this deals with distance, is ask, is this possible? Can a distance be less or equal to 6? Well, yeah, it could be 5, 4, 3, 2, or 1. So yes, that's possible. So case 1, we're just going to copy the problem. So 2x plus 8 is less or equal to 6. Case 2, 2x plus 8 is greater or equal to negative 6. So again, we flip our sign and we change it to a negative. So this will cover all negative and all positive versions of what gets a distance of 6. So over here, 2x would be less or equal to negative 2, which means x is less or equal to negative 1. Over here, we get 2x is greater or equal to negative 14, which means x is greater or equal to negative 7. So now that we've solved, we're going to graph our answers. So negative 7 comes first on the number line, and then negative 1. You'll make sure you put these in the right order. Solid circles on both, since it's inclusive. We want numbers less or left of negative 1. Numbers to the right of negative 7, so it looks like we're going to have a connection here. So we are going to present our answer as an AND, which means we need to show x is less or equal to negative 1 and greater or equal to negative 7. So any number in that range will make this statement true. We're going to try another one. So once again, start off, can distance be less than a negative? Now think about that. Distance cannot equal a negative number. We learned that that's not possible. So it certainly can't be less than a negative, because that would still be a negative. So like anything less than negative 4 would be negative 5, negative 6, negative 7, negative 8, and so on. You'll never get a positive distance. So right off the bat, we're not even going to do this. We're going to write no solution. You can't have a negative distance. For number 3, we need to isolate our bars first. We learned that in 6.5. So we're going to need to add this 3 over as our first step, leaving me with 2 times the absolute value of x plus 4. And they're saying that should all be greater than 20. I still need to get rid of this 2, so we're going to divide it. So my answer is the absolute value of x plus 4, or the distance of x plus 4, must be greater than 10. So yes, this is definitely possible. So we'll go ahead and make our cases. There's our case 1. In case 2, we're going to switch and change to negative 10. So my first answer will be x is greater than 6. My second answer will be x is less than negative 14. And now we're going to graph negative 14 and positive 6. This is not inclusive, so open circles. Greater than 6 would be to the right. Less than negative 14 would be to the left. So all I have to do is put the word or in my answer and I'm done. Number 4, I see a negative number here. So it looks like it would be no solution because you can't be less than a negative. But we're not ready to make that decision yet because we need to add this 8 over. So you always want to have your bars isolated before you make a decision. So 4y minus 5 is less than 6. So this is possible. You can have a distance less than 6. So we definitely want to set up our cases once again. So my first answer will be y is less than 11 over 4. My second answer will be y is greater than negative 1/4. And then I'm going to graph. So negative 1/4 comes first. 11/4 comes second. Open circles. Less than 11/4 would go this way. Greater than negative 1/4 this way. And we are going to have a collision. So my final answer needs to be written as y is both less than 11 over 4, but also greater than negative 1/4. So these are all my possible answers for y. So what I did is I typed up a little summary of when you want to be cautious. So for example, when you have a negative number, that means you're going to have a special type of answer. So this translates to distance is less than negative 5. So that statement in itself doesn't make sense. You can't have a negative distance, and you certainly can't have more negative distances. So anytime you have less than a negative, you'll have no solution. For this problem, numbers whose distance is more than negative 5. Well, every number in the world has a distance that's more than negative because every number has a positive distance. So the answer to this would be infinite solutions. No matter what you put in for x, you'll always get a number bigger than negative 5 because you'll always get a positive answer. So when we have these negatives, we need to decide no solution or infinite solution. For a problem like this, however, this just means distance less than 12. The bottom one means distance more than 12. So result, you're going to have to set up case 1 and case 2. So negative numbers are a problem. We do not set up cases. You make a decision, infinite or not possible. Problems that are possible where you have positives, you have to go into case 1 and case 2 to figure out your range of solutions. And of course, we don't want to forget about our equation. So for example, distance cannot be negative. So we want to make a little reminder to ourselves. Distance cannot equal negative. That's not possible, so we would put no solution. Absolute value inequalities. Distance is never less than a negative, and distance is always greater than a negative. So a negative answer, you can't have a distance less than a negative, so no solution. The other scenario is you will always have distance greater than negative 8, no matter what the number is. So you just have to watch out for these negatives, okay? It's either no solution or infinite solution.